We show an example of multi-level analysis, multi-level processing. As indicated by the name, multi-level analysis means that the statistical analysis will be performed at multiple levels, where the lower level produces information that is then passed to the higher level to analyze. Typically also the number of conditions, number of cases being distinguished will be lower as the level increases. That sounds all pretty theoretical. Let's take an example where this occurs. This is data from a Fitts law experiment in 4 different interaction conditions, which is quoted by the second column. Actually, these 4 conditions arise by having 2 devices, either a pen or a mouse, and 2 orientations, stimuli in a horizontal or vertical direction, being used in a Fitts law experiment and for 8 subjects, which is indicated by first column. So 4 interaction conditions, 8 subjects means actually 32 combinations. In each of these combinations, a subject performs 9 different tasks, of which the time is measured, because the task is also repeated a couple of times. So the first level means that we have to analyze the information for each of these combinations separately, and then for each of these combinations we will pass certain information on to the second level. Let's see how this works out. So let's read in the data set. So at the lowest level we analyze the task performance, and we do this separately for every of the 32 combinations. So we will analyze the time versus the task difficulty, which is coded by the stimulus distance over the stimulus width, and we use Fitts law modeling, so a logarithmic law applied to these task difficulty. Now this takes a little while since he's reading in 32 data sets, and so they're all regressed against this simple pattern. And so if we look at the output, we have a table showing all the 32 analysis for the 32 combinations. Now we have to add a code to pass this on to the every time we have 4 different interaction devices for all the different subjects. So we enter this code into the table, which we will then pass on to the next level. So this is a bit slow. You could also do it to an external editor. So we're going to save this table. And now we're going to go on to the next level of the multi-level analysis. And so we start a new ILLMO session, and in this next level we will only have 4 conditions, namely the 4 interaction conditions, and we read the file that we have just created. So the code that we have just created contains the condition, and we might, for instance, look at certain outputs of this first level analysis, which is the gain and the offset in the Fitts law description. So if we looked at the gain, we could, for instance, create confidence intervals using empirical likelihood, since the distributions are not nicely Gaussian. And we create a pattern like that. Same thing for the offset values. We get an impression of how they distinguish for the different interaction conditions. So we might also create a 2D pattern to see how these two attributes relate to each other, so the gain and the offset. And what we do is we just use this pattern that we just created for multiple regression, and we do this for both, which means that we get an impression about how the gain and how the offset varies as a function of these four conditions.